Okay, example 9, we're going to be finding the angle between two vectors. So just to give you a visual of this, if you have vector 1 goes this way, let's say vector 2 goes that way, whatever direction they go. There's two angles that exist. There's this one here, and then you got this one here. Looking at it, I can see very clearly that it's less than 180 this way, more than 180 that way. This is the smallest non-negative angle, so the alpha that we're talking about is this angle, alpha here. And the formula tells me that cosine of alpha is equal to this dot product of the vectors on top, what we just looked at, and magnitude of v, magnitude of w, so the product of the magnitudes of the vectors on the bottom. And this right here is going to create for us a number. Cosine of that's going to equal that number, so inverse cosine of whatever this number is gets us the angle. All right? And on top of that, if v dot w happens to equal 0, so if v dot w equals 0, it's going to be a 90-degree angle, and the vectors are said to be orthogonal. Orthogonal meaning at right angles to each other, which is also perpendicular or normal. They keep coming up with new words for what perpendicular is. So if the angles happens to be 90 degrees, the vectors are said to be orthogonal vectors. And that's going to be one of the questions on the homework. So if you get a 90-degree angle, they want you to write it. If it's not 90, not orthogonal. So they want you to identify that. So, but again, the formula, dot product on top, product of the magnitudes on the bottom, and cosine of alpha equals that, then we simply inverse cosine that number, and we get our answer. And v dot w is always going to be smaller than this, so we're not going to get undefined on these. So there's always an answer. So, try it out. Find the measure of the smallest positive angle between the vectors v and w as shown are the vectors orthogonal. There's that orthogonal question. So, if we take a look, vector v is 2i minus 3j. Go ahead and write it in component form. And w is negative 1i plus 5j. So, going to this formula, it tells me that cosine of alpha is going to equal v dot w on top. So v dot w is just what we did in the last problem. So v dot w. So 2 times negative 1 makes negative 2 for the product of the horizontal components. Negative 3 times 5 makes negative 15 for the vertical components. And again, it's plus that negative, but if I just put minus, that means the same thing. All right. On the bottom, I've got to do magnitude of v. When you do magnitude of v, we're going to square the components of v and add them together. So, and I like to square things mentally. Everything's positive when you square. So 2 squared is 4, 3 squared is 9. Then we have magnitude of w is going to be the components of w squared and added together. So that's going to be 1 squared plus 5 squared. So that's job 1, is to actually create the structure of this thing, doing all the mathematics necessary. And again, if you got a component form, it's very easy to do that. IJ form's still easy to do that. So take your pick how you want to write it, but I kind of like component form on these. It's my personal preference. So I get cosine of alpha is equal to whatever it equals. In this case, on top, negative 17. On the bottom, I get the square root of 13 times the square root of 26. I'm not looking for exactness here. An approximate value is good enough. 4 decimal places, plenty to get a 2 decimal place approximation. So what I want to do is I'm going to type this expression in my calculator. There's always going to be a product in the bottom, so be careful that the thing is typed in properly. So when I type it in, negative 17 on top, divided by, I'm going to put a parentheses for the bottom. In fact, you know what I'm going to do? I'm going to do this. I'm going to do square root. All right. The square root of 13 times the square root of 26 is the same as the square root of 13 times 26. Okay, that's same thing. And by putting the m parentheses there, that encases that entire thing on the bottom. That'd probably be the easiest way to type it in. I like to minimize the number of parentheses in my expression. So again, square root of this product, end parentheses, that puts the entire thing on the bottom, and that's the equivalent. So hit equals, and we get negative 0.924678, whatever. So cosine of alpha equals negative 0.9247. So that means alpha is going to be the inverse cosine of that number. So second cosine. If I did answer, that already goes out a bunch of decimal places. That's actually more accurate. For the sake of having it in my work, I'd like to have at least 4 decimal places there. But again, if you inverse cosine the answer, you're actually more accurate, so it doesn't hurt. 157.62 degrees. Okay. And just so you see, that's drawn to scale. All right, if I actually had a protractor out, hopefully it's going to be 157.62 degrees. Kind of embarrassing, but it's not. Let's try it out. There it goes. So yeah, let me shrink this up a little bit. There we go. There's a way to shrink it up. There's 155, 6, about 7, 8, somewhere in there, which verifies that. So again, that just verifies that it works, but you don't have to measure it with a protractor. That would be another way of doing it. If you draw everything to scale, get a protractor, you can measure it. But this is actually much more accurate because it gets down to the whatever decimal place you need to get into. And again, that's how the formula works. So it's inverse, our cosine equals, you have to inverse cosine, whatever that is, to get the answer. The angle is what we're looking for.